Done.
Okay, cool. I started recording. Excellent. Okay. Good morning, good afternoon, good evening, everyone. Folks, thank you for joining Large Scale Scrum New York City meetup. Today we have Viktor Grgic back in the studio with us. Viktor did a great job a couple weeks back discussing the topic of customer proximity in large scale Scrum. Today we have a slightly different topic. Viktor is back to talk about independent teams and microservices and why this would be a bad idea to couple the two. So he shall do the justice there, explaining his points of view. Without any further ado, I will pass this on to Viktor. I will just say to you, those that may be joining this for the first time, I haven't seen Viktor speaking last time. He's a large-scale Scrum coach and trainer, blogger, publisher with many years of experience. Currently, he works out of Hong Kong, but he started his career almost 20 years ago and has been through Netherlands, the UK, and Japan, and other places in the world, working in consulting. So we'll pass this on to Viktor, and he will budget his time, and we'll take his questions as they come or at the tail end of his presentation, okay? Viktor, let me pass it on to you.
Good. Thank you, Gene. Thank you for having me here. And if somebody wants to turn on their camera, I would appreciate that. Why? Because I'm very much into seeing and interacting with the people. I'm used to that in a physical thing, and so I'm still need to get used to this Zoom thing. So I like that. So, but it's up to you, obviously. And thanks already. Quite a few people.
Camera does not mean mic. Yeah.
Yeah.
Self on mute still, but do give your face if you can. Excellent.
Yeah. Although having small children jump into the screen, it's always lovely. But anyway, let me share my screen. It's this one. Okay. Good. So you should see my first slide, right? Good. Okay. So we going to talk about independent teams with microservices and why it's a bad idea. So I'm going to do my best not to base that on opinion, but based on actual reasoning and experience of simply being in product development a lot. And so let me first start to talk about a bit of a background where this comes from. So I've been in a product development for quite a few years, about 25 years or something, and I used to be for a long time called architect, software architect. So I've been dealing with that for quite many years, and I used to have also training in how to deal with the architecture in more iterative way, etc. So what I've noticed in all these years, and that for me, actually the number one reason why product development, when it fails, why it fails, is a mess in architecture. So it might be surprising. I noticed in all these discussions, etc., we talk about the project management failed and a waterfall way that's actually caused a failure. For me, not really. It's the mess in architecture which is actually the main failure. And things become so damn complicated at some point that you cannot deliver anything. So, but obviously it doesn't stand on its own. It's driven by a lack of technical excellence. So people simply don't have the skills and ability or the means, or they have already a mess. And so this lack of this technical excellence creates a bigger mess. It's kind of also a reinforcing loop. Once you have a mess, then it tends to become bigger and bigger. So and then again, you could ask yourself, what's the cause of that lack of technical excellence? How come it's not everybody's doing clean code and proper architecture, etc. after all these years? Well, there are one of the major reasons is dysfunctional organizational structure. You have a certain, your teams and developers are working in a certain organizational structure, which is often not incentivizing to do this kind of a stuff. So you have all kinds of weird thinking, like teams shouldn't be spending too much time cleaning code. They should just deliver, etc., etc. You're probably familiar with that. And what happens then in reality is that somebody comes in and it comes with a brilliant new solution on how to solve this problem, and it's going to be just like that. And we're going to talk about that. So one of those things is you just split the teams apart, and each of them have a bunch of microservices, and suddenly all this mess is gone. And that's also the main attention here. I'm going to explain in detail why this is just a simplistic theoretical nonsense, and we need to be very careful and also emphasize how dangerous that actually is. So what do we mean first by independent teams? So the subject of the talk is independent teams with microservices. So there could be a number of definitions, but I want to emphasize just two, and two different ones. So the first one is the independent capability, so the below one. And we're not going to talk about this one in the talk, except at the end. So independent capability means that each team on their own are able to deliver a customer request end to end. But all the teams are working on the same thing. They're basically sharing the same product, and they somehow needs to collaborate to deliver that. But there is an independent capability. So this is a good thing. If somebody means independent team with independent capability, this is great. I'm not going to talk about that. I will focus on the teams on a definition which implies there is an independent work, which means that each team separately has a separate focus of work. So they focus on part of the product, and in this case then called one or few microservices, and therefore they don't need to collaborate with other teams, because they just need to deliver their part, and the rest is delivered by others, and they can also deploy independently, etc., etc. So the main message is we should really avoid this type of independent teams. And so what kind of dependencies are we talking about here? And just to kind of reflect, when I say dependencies, I want to make clear what do we mean by that. So there are different types of dependencies, and the first one is between customer requests, or you have one large customer request and it's being split up in smaller items, and those smaller items have a certain cohesion, and that cohesion needs to be preserved. So you cannot just have all the teams deliver all tiny bits parts and somehow expect that user experience is going to be great. It doesn't work like that. So there has to be some cohesion. Then we have on architecture. So each team, they are making, obviously, while delivering something, decisions, and those decisions needs to be aligned with each other. So having each team separately making their own decisions without alignment is a recipe for a mess, and also needs to be aligned with the product and company strategy. The third one is having a shared component, code, applications. So simply because you want to avoid duplication, etc. And so different teams or different groups in the company, or even certain parts can be developed by the separate company. You can imagine if you, depending on those parts, and those are the shared parts, then you have a very painful situation. So it's you can imagine a very common situation that you want to do agile, deliver every 2 weeks, but you have a separate company which is having a traditional process which it takes 6 months to deliver it, and therefore you can do agile whatever you want, but if you depend on them, then everything takes more time, obviously, before you have any kind of a feedback loop. Now, these are the main type of dependencies that we're gonna address and talk about it, and But there are obviously additional ones, which I'm going to assume it's already kind of understood and given for you that that should be also this is also important, but we're not going to touch much about those. Is when you have a dependency on information, knowledge, or experience. So, for example, one team needs to deliver something, but they require information in order to do that, or they require specific knowledge, like I don't know, about security or about regulations, etc. So this is a dependency. Obviously, you need to bring somehow that dependency in the team. I assume we agree upon that. And then the last one is ability, authority to decide. Well, this is very much connected to being a self-managing team. So I'm going to also assume that we more or less agree upon that we want teams to have ability and authority to make decisions. Otherwise, forget about agility. So the first problem, if you have dependencies, or a first manifestation that I see, and it's damn common, is the type of a we don't care. And how does it manifest? Well, the team simply focus on their part, whatever that part is, and or maybe they focus on more than that part. And but the working with others is so painful, and that they're using all kinds of practices to postpone the pain, basically, and to deal with it later. So they wait on each other, and the most common practice is branching in a code. So why the way of branching is because we have this manifestation of behavior of we don't care, and so each team, they just want to get done their stuff, and how it's going to fit together, they don't know. There's just too much to focus on anyway. So this is the first one. It's a very, very costly one. So the cost of dependency, this kind of a dependency, is very high, because it becomes very painful when you start to merge things back together into a single product. Considering that we have a, so what happens in a world, and somebody has kids? Yes, good.
Oh, please mute yourself.
Yeah. And it's always lovely to hear the kids' voice. And so what happens is, considering the previous point of teams which they focus on their part, it means that somebody needs to make sure that all fits together, that these dependencies are managed, basically. So the traditional, the famous one that we had for ages is the Gantt charts. Okay, so we had this. Maybe muting would be nice. And so I don't know, Jean, can you maybe mute?
You have to give me back control, and then I'll be muting everyone. But
okay,
David, that's you. Could you please mute yourself? Thank you.
Yeah.
Go ahead.
Let me go back. And so what happens is that you have these teams, and these teams, they focus on their own part, and somebody needs to take care of dependencies. So assumption is that you need to take care of dependencies by some kind of an outside force, and outside groups of people, process, whatever you want to call it. So the traditional one is the Gantt chart, and where each part is being done by one group, and at some point that is being handing over to the next one, etc., until it's finished. So this is a typical Gantt chart. The funny thing is, nowadays we have exactly the same thing. It just looks a bit agile-ish. We have instead of a Gantt chart, we have basically Gantt chart, but with a red cord and a post-its. Just look at it. It's exactly the same. It has also cord. You see, the Gantt chart has also cord and everything. There's no difference, basically. Just to make it, sure. It's just we suddenly call it agile because it's with the post-its. And on top of that, on top of this kind of a processes and this kind of a practices, we have also coordination roles, a whole bunch of coordination roles. Previously, what roles that were typically, this is my observation in organizations, the roles which had previously had a bit more specific set of responsibilities. Nowadays, they are more kind of doing all kinds of types of coordination. So this includes the so-called product owners, if you have lots of them. And those product owners start coordinating with each other, scrum masters, train engineers, project managers, team managers, and on and on and on like that. And to make things even more a circus, you suddenly put those people in these pentagons and call them executive meta scrum and so on and so on. So the whole structures of dependencies, this is, while the actual original problem of the root cause of having dependency in the first place and what is exactly are we dealing with, it hasn't been solved. So we are just keep managing stuff instead of resolving them. So, so let's agree, and I think we all agree that dependencies are painful. Okay, we hate these dependencies. They're costly. They're very costly. That's why we hate them. So that's very understandable. And in order to get things done with the many teams, and there is so much in between things, people waiting on each other and ways that you need to solve it somehow. So let's go for a nice simplistic solution, which is we have a solution which is called microservices. Each team has their own bunch of microservices, and these they can deploy independently from each other, and they can they're also customer centric, so they can deliver the feature and for the customers, and that's the whole idea basically. There's also a book, Building Microservices, Sam Newman. I would definitely advise to read that book. It's actually a really good book. And especially because many proponents who are deploying this approach of microservices in order to solve dependencies between teams never read the book, and I'm very sure of that. So most of the microservices deployments are done by the people who don't understand the whole concept. And this is especially obvious when you talk to Sam Newman, who himself says that most of the organizations who ask him to help them introduce microservices shouldn't be doing microservices at all. And one of the main proponents of microservices who says this. The first problem. So let's dig into the details. So I'm going to move away from this kind of statements. The first problem when you're having such an idea is that you have a team which is focusing on a certain set of microservices, one microservice, is that who is actually delivering the important stuff. So let's imagine that you have in whatever way, in a product backlog or whatever way, a list of stuff that the company wants to achieve. And obviously they prioritize. They say, this is the important stuff. This is important maybe later or maybe not important whatsoever. We just think it's maybe important. So let's now imagine, not imagine, it's actually the reality, quite normal, is that the first bunch of items for the deadline of the first month or something requires the work from a team A and team B. Because the changes required are only the changes in microservice A and microservice B. And so for the microservice C, so let's say the microservice A is the actual, let's say it's a mail product. It's a Basecamp Hey mail client. I don't know if you heard about it. So a new mail application. So there is one team which is building the actual mail application. A second team is creating the platform to sell it. Okay, so to the payment for subscriptions, etc. And the team C is for the support, all kinds of support activities. So they're focusing on that, and each of them is done in a separate way, and they kind of are separate from each other. Well, if the most important stuff is A and B, what is team C going to do in the meantime? Okay, especially because the stuff that the team C is required, or a microservice C is required, it's something for the next year maybe, or the rest of the year, but not for the next month. And so you get the problem of actually prioritization. So the dirty hacks of solving this problem that the organizations are doing is they start to shift people between teams. So they start to mess with the teams basically. And this shifting generally doesn't produce any benefits, since people need to first learn, get accustomed to the new structure and new service or whatever. So generally shifting is just wasteful. It doesn't produce much of a benefit.
Good job.
And And the second one is that it's letting go of the idea of doing the important stuff. They prioritize based on the ability of the teams and not importance. So they kind of give work to the team C, regardless if it's important work or not important work, simply because you're uncomfortable teams not doing anything. So you kind of optimize for busyness and not for achieving some very important goal very soon. A less dirty hack, which is occasionally seen, is that the teams start to work on each other microservices. So that's how it's being done. So just think about it. So the whole idea of microservices is that teams can work independently from each other and on their set of microservices. And in order to solve this problem, they actually dropped that idea. Well, I'm not sure why then. Yeah, then the whole idea is basically dropped, which is good. And yeah, but. The second problem is the expertise in domain-driven design, I notice. So by far the most, if almost all of the companies which are doing nowadays microservices have no clue about domain-driven design. It's very little knowledge about it. And especially considering how long this concept exists and how long Eric Evans has written a book, and there are a whole bunch of books, and how little people actually know about domain-driven design. It's really, really important, and generally just as a body of knowledge to know how to design stuff properly. And I'm gonna touch a bit the details of it so that you understand the basics in the context of microservices. So there is something called bounded context. So you imagine that you are in a certain domain, and the domain can be split up in a specific context for a specific purpose. Let's say one purpose is for selling a product, another one is for supporting a product. And so obviously in both of them, you're talking about the customer, but the customer in selling the product is something slightly different than customer in supporting the product. Although it's the same customer, the information might be different and perspective is different. So, so you differentiate this kind of a stuff by creating a so-called bounded context. So generally microservices are organized within the lines of a bounded context. And so teams are generally focusing within one bounded context or maybe few. Within that bounded context, there is so-called aggregate, and aggregate is the top-level entity which defines the transaction boundary for the changes of a specific of a certain information. In this case, it's you have a vinyl, and there is a certain information belonging related to vinyl. So if you want to change any information below here, like an album, artist, or genre, or whatever, you're basically first instantiating the vinyl and then doing the changes and a finishing transaction. So why do I explain this? Generally, if you develop a microservice, it's within the boundary of this aggregate. So the web service is microservice is basically taking care of this aggregate. That's what the microservice is then all about. The rest is all just a bit of a technology surrounding it. So, but I'm just touching the basics of it. There's a whole world behind it that one has to know before doing any sensible thing about microservices. Third problem. So this problem is that if you are not expert in domain-driven design, it's going to be a mess by definition. Okay. And third problem is the handling customer request. So you have a feature request, and that feature request, from a customer point of view, in order to fulfill something meaningful, requires changes across multiple microservices. It simply happens that the user wants certain experience. So in this case, let's say it's a mail application, and you want to be able to, let's say, take the Basecamp thing, mail. You want to be, they have to have people pay through the Apple platform. And so what they do is they obviously need to adjust the product, how it actually works. Then they need to do something about the sales and the whole payment system, etc. And then they also need to provide support to the user. So it's basically a same feature, and cross-cutting all three of them. And so which means that you cannot have just a single team just like that handling independently from other teams. So dirty process hack, in order to, what I observe happening is that they split the items until they are not customer-centric anymore. this means basically that still all these separate parts, tiny parts after splitting, still somehow need to come together. You still need to do integration testing, and you still need to test it in all combination. I assume that you're not going to deploy a microservice independently without having integration tests properly first. So there goes your independent deployment. And so whenever you have such a feature, which is cross-cutting multiple microservices, you cannot deploy independently from each other. So one argument that I hear against these problems is, but we have resolved the problem of crossing boundaries by better segregation. Our features don't cross bounded contexts. Okay, so this is the bold statement being made. Already the statement sounds really, you should be skeptical about it because especially if you have 25 years of experience in this area, then you know how complex product development really works, and that it's this is theoretical thing. So I found out actually how they achieve that. And so there are companies which have achieved that, and they achieve complete segregation despite the complexity of the product. So each microservice is doing separate things from each other. Well, the problem is the solution is a shared library, and which brings me to the problem of a shared library. So shared library solution is as follows. So they notice that the microservices are doing, they need a same type of a partial code. So there is a certain part of microservices which is same. So they obviously want to avoid duplication. Okay, so whenever you make a change in some rule or whatever, you don't want to make it in a multiple microservices. You want to make it in a single code and not having duplication. Duplication is evil by definition. I hope we agree upon that. And so what happens is that they create a library, and that library is then deployed in each of the microservices, okay, in order to avoid duplication. And then what happens is that whenever you make a change in a shared library, and that's especially then painful when a shared library has a significant amount of code, and that code changes regularly, then you have to actually redeploy all those services again. Okay, so you every time you make a change in a shared library, you're deploying all the services that have used that library. Okay, so then which becomes quite painful. And so imagine just comparing that to having a monolith. If you're having a monolith, you don't have that problem. You just deploy that one monolith. That's it. Okay. So then, in order to fix that problem of continuously deploying over and over again, nonstop, all these microservices, whenever a single change happens, they have a first dirty hack, which is work with the multiple versions of a shared library. So they create multiple versions of it, and then in time they hope they're going to clean it up. Well, guess what? It doesn't get cleaned up. It just gets more messy because of the so many versions of the same shared library. So then it comes the nasty hack. When it becomes a mess, they fork it. So they split again the shared library, so it's not shared anymore. Okay, and now we have an even much bigger duplication, and so it's just a one big mess. So what happens at that point in time? You kill the whole microservices and you go back to monolith. So if you wonder at this point, like, yeah, this is theoretical, then I would advise to look at the talk from Alexandra Noonan. It's a brilliant talk where she explains from an actual story that where this happened. I would strongly advise to watch that. And so shared libraries in this context, it's absolutely not a solution, basically. It's just creating a mess. What's the underlying problem here? How come this cannot be solved? How come we cannot split things up properly? I mean, it must be possible. Well, it's not possible. There is a very simple reason for that. There is this basic rule in design of software. It's called high cohesion, low coupling. It doesn't say no coupling, high cohesion. Okay, it says low coupling, and we need to be very much aware of that. Why it's not no coupling is because if you couple things from each other, it's not a product anymore. There is the whole benefit of having a user experience of a product means there is a certain coupling between parts. All we do when we do design is try to find the proper balance of having as little coupling as possible and still have having a cohesion where things really belong to each other. so that when we change something, it doesn't affect too much the other part of the product. Okay, it's low coupling. So this is the fundamental problem, which makes microservices idea of splitting between teams impossible. Then we have a fifth problem, which is let's assume that the proper architecture is being done, which means by definition you're going to have some shared services. Okay, so you have certain shared parts, common parts, which are used by multiple microservices. So that begs the question: who's responsible exactly for which of those shared services? Who's going to actually take care of those shared services? So what typically is done is that one of the teams takes one of those services and become responsible for it. So which means that you have then dependencies between teams again. And so other team needs to wait for this one team to finish the service before they actually can finish their part, and so on and so on. So how do they solve that? Well, they shift the experts between teams, which we talked about it, and so which is yeah, not a good practice, and I mean a harmful, wasteful practice. And besides, you also have this bottleneck problem. If you have, if you use one shared service a lot by lots of things, then you typically have too few people to help you continuously. And another one is to split requests into even smaller technical requests and manage dependencies. We already talked about that. And the last one is interesting. It's they start to have an internal open source approach, and where you where anybody can change basically any service. So all those team A, T, B, D, C can change any of the shared parts, whatever they need to change. Only what you have is a code custodians, which need to make sure that things are done properly. This is funny because now we are moving actually with this solution. This is coming from a microservices world. This is actually from a Newman book from people who actually know really how the microservices world really look like. And so you basically start, those teams cannot be then fully independent. It's just not possible. This is acknowledged then. And you get these sharing practices between code. So considering that you have these sharing practices and that you have that you actually have to share, but teams have to share things between each other. What we then say in less, therefore, why don't you then completely share with each other? Okay. So what the real solution is that we have to separate the team structure from architecture. We shouldn't have done that in the first place. The whole idea of having teams connected to the architectural parts is just complicating things. Okay, so instead what we want is that each of the teams is looking at the whole product, and each of the teams is taking a customer-centric item, and then they implement that customer-centric item by touching the components that are required in order to implement that customer-centric item. Okay, so therefore the whole product is basically, in every part of it, of the system, is shared between all teams. Does it mean that all teams have to know all components and services, whatever you want to call them? No. Because they're going to specialize probably from a customer point of view. So they're going to implicitly also touch only those parts which are often touched for that type of a request. So never one team needs to touch everything, but there will be a certain amount of sharing that multiple teams need to touch the same code and deal with the same code. This begs the question, if you have lots of people touching the same code, that's going to be a mess. Yes. Therefore, technical excellence is a really crucial part of this. If you don't have technical excellence, then it's going to be a mess, absolutely. So instead of having team owning microservices, what we should invest much more on is the technical excellence, which enables the sharing of the code, where you have where you can have many people touching the same code, and where those people are in time improving the code. I have a whole separate story about the actual case study where this happened, and it had an incredible good effect. So all team members could change basically anything, and without even having a mandated code review. So anybody could push anything to the production, basically. So when it comes to dependencies, what do we do with that? So instead of avoiding or postponing or trying to cut those dependencies, which, as I demonstrated, doesn't make much sense, we should reduce cost of dependencies. So dependencies should not be avoided, should not be managed. The cost of it needs to be reduced. How do we reduce the cost of it? Don't have people outside of the teams manage dependencies, because it's going to be costly by definition. The team should be managing the dependencies, and in other words, teams should be coordinating with other teams directly. The more they directly coordinate, the less of the cost you're going to have, simply because of the handoff and the knowledge required in order to do that. Second principle of how to reduce the cost of dependencies is having synchronous over asynchronous coordination. So this means if I want to get something done, I'm going to stand up now and walk over or connect through Zoom with another team in order to get things done. I'm not going to send an email or wait for a meeting or wait for a PI planning or whatever it's being called. Okay, so I want to get it done now. And therefore, don't manage dependencies, but get things done, basically. It's simple as that. Now begs the question, some of you might be familiar with the Conways Law. For others, I'm going to mention briefly what Conways Law is. The Conways Law says that the architecture is going to resemble your organizational structure. Okay, so if you have an organizational structure which is one of the famous statements was if you have 4 people working on a compiler, they're going to be a 4-step compiler. So because each of them needs to work on their part. Okay, and so this is very true, this Conways Law, absolutely. But now comes the interesting part of the Conways Law, which is very often overlooked. Okay, so this is from a children's book my son has, and I found it very actually applicable for this case. I'm going to translate from Dutch to English, and it says, the next day on school, the friends of Tip were playing together, but the Tip doesn't want to play with them. He's sitting separately and he's holding his toys very strongly. He doesn't want to share with others. But now, since he's now he's sitting there alone, but his friends are having fun, and so Tip thinks these are my toys, and he looks a bit angry. But Tip has it completely wrong. In school, the toys are for everybody, and that's the whole fun of it. Okay, so the big question, which I'm not going to answer this time myself, I'm going to leave the time for questions, is what happens to the Conways Law? What happens to the architecture when you have everybody responsible for all parts of it? Okay, that's the question. Questions, please.
Hey, folks, feel free to unmute yourselves and just ask a question and then mute back so that we have not too much background and interference. There's some questions in the chat room, by the way, if no one steps up.
I cannot see chat room.
I'll paraphrase if needed.
Oh, I can see now. Yeah, maybe if somebody,
yeah. Anyone wants to ask live questions, folks? Why don't you take?
Hi there. I actually do have a question.
Sure, please.
Thank you very much for your presentation. In the 5th problem that you described, where there's a shared service architecture, there's a couple on that slide there. There were a couple of bullet points that sounded like they sounded familiar, like recommended techniques from one of the less books. I can't remember which one. It was like the expert who like resides on another team for some time for the purpose of knowledge sharing. Was that listed there as not a recommended method for dealing with shared services, or was it listed there as a proper way of dealing with the problem of shared services? Does my question make sense?
Yeah, your question is very good, and I'm very pleased that you are referring to the books. So the crucial difference here is that the practice that you're referring to is about people moving from one team to another to teach other teams so that they are able to take care of the services and components, etc. In a world of microservices, it's meant to have those experts actually change the microservices and change stuff. And
for the team, like go in and make the change and then leave,
exactly.
rather than actually transferring knowledge. I see. Okay, yes. Great, thank you.
You're welcome.
And I think you were referring to the developer traveler concept, if I'm not mistaken.
Yeah, that's right.
Yeah.
That's right.
Okay.
Yeah. The one question in the chat was, how about consumer-driven contracts? Those tools are solving the problem of features crossing microservice and independent deployment development. How about consumer-driven contracts? I don't understand the question. Consumer-driven contracts.
Yeah, that was JNB. I'm sorry, whoever posted it. Could you please explain what you meant by the question? The initials are JNB, not necessarily a full name. Whoever posted a question, could you please voice it?
Otherwise, we move for now to other question.
Yeah, go on. Go
on. Is it good to form programs with multiple specialized MS teams in a building platform?
Microsoft, I guess. Yeah.
Oh, Microsoft Teams.
Yeah.
Building.
I think they meant microservice teams.
Oh, microservices teams, yeah.
Microservice.
Is it good to form programs with multiple specialized microservices teams in a building platform? I'm not sure what the question means. Yeah.
Hey, Ravi,
Ravi, can you maybe speak and explain what you meant? Microservices teams while building platform. What kind of platform are we talking about?
Hey, sorry. Yeah. I'm in a noisy background, so that's why I couldn't. Well, we are building a core platform, core banking platform, or core insurance platform. There are multiple moving parts, and each of these will be different product lines, probably, right? So in that case, is what they generally do is, this team, you own all the alerts that has to go to the customer or to the internal, etc. They set up certain teams. You manage only all the traffic that flows from one end to another end. You take care of the orchestration or the choreography of the system. Like they specialize teams based on the type of functionality of the platform, and create a lot of reusable components, which they feel that it helps them. So the teams go and ask about, let's say when they have a product owner, when they go and find out what kind of work they can work on, they go and talk to different teams and get the work and start helping them, right? So, or building that particular capability, having a specialization, but customizing it for other groups, other product lines. So that's a type of, in a large picture, imagine that's kind of close to 10 teams, 20 teams, purely performing such type of role.
Okay. Okay, that sounds very much as a component team thing. Yeah, to put it bluntly, that's even worse than a microservices situation because they are not even customer centric. They are basically doing a certain part which is only in a combination with other parts, delivering something that benefits the actual, that has a business value. Am I correct?
Yes, yes.
Yeah, so that's even worse. That's a typical what we have and teaching less a lot about the component teams versus feature teams. I can point you to quite a lot of material about that. I wanted to talk in this talk about microservices because they are theoretically and in reality also customer centric still. So they are delivering supposedly something for the customer, and yeah.
Okay. If you can throw a light on how this is different, component team is different from a microservice team, that would be helpful.
Yeah, sure. Yeah, we can. I can definitely share that. Yes. What are your observations on who is responsible for architecture in the teams you are working with? It seems like by default it is everyone and no one. Good question. One thing for sure is definitely not everybody in teams, and simply because you have different types of people. Some are more senior than others, and it's simple as that. So in less adoptions, the architects, at least the real ones, the ones that actually know how to code, they end up in a teams, and they have a real knowledge and they become a team members. So it's not like the people are with the knowledge gone or something like that. They just move into the team, so the teams can deal with that, and not everybody in teams deal with that. It's the more senior people. And so that's the first one. Not everybody is going to be involved in architectural aspects, but at least more than just one individual if you have one architect, and that's good. The more, the better. Second one, the most common practice of dealing with architecture is the architectural community. So there are certain individuals from teams which get together regularly, and they have a platform together where they discuss architecture. The architectural community is also the most common community, so which is a cross-cutting across the teams, and they are dealing with those subjects. And yeah, this is how it happens basically. So it's in reality never everyone. That would be lovely, but it just never happens. Yeah. How to deal with points of failure when introducing the service component code custodians? How to deal with the points of failure?
Viktor, you talked earlier in one of your slides about these custodians as a role. When you talked explaining the very many facets of opening up code to many people, and the first question that comes to mind is single point of failure. I don't know. Somebody overlooks something, somebody has a different architectural decision on something, somebody has a different scope of information than somebody else, somebody gets sick, somebody dies, I don't know, changes the company, you know. What do you think about this?
You mean if custodian leaves or something, you mean like that?
That would be one example, but the general question is, you introduce a single point of failure when you have one single custodian, because if you remember, since the 70s, 80s, we've always had that problem with data custodians. So
yeah, I agree. So maybe it's probably my fault. I wasn't really clear. I was explaining why the idea is bad. So I just explaining what normally happens, and yeah. I guess I didn't emphasize that having these custodians is a bad idea. What's alternative? Because you also don't want to have a mess, you know. So some people are going to touch the code, and which they don't really fully understand, etc. So how do you deal with that? Well, you don't have a custodians, but you have a mentors. So what's the difference between custodian and a mentor is that the mentor is not the gatekeeper. So people are themselves responsible, and they're using a mentor as somebody who can help them take that responsibility. So if the mentor is not around, they can still do their job. Okay.
Responsibility means if you mess up code and leads to problems, something happens to you, or you have to put on the brakes next time you want to change something, or something like that. So crowd wisdom or crowd punishment, if you want.
Now, I remember vividly how one of the practices developed in less adoption, and we had this build server which had this rocket thing. So whenever somebody break the build, it would shoot a rocket, and you had to buy a cake and blah 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 blah. And then we thought about it, and so what's going on here? Because I mean, it happened quite often that the build got broken. And then we started to think, how come actually that the bill gets broken? Why? What were the reasons? And then we noticed there is simply a problem in doing certain practices, or a quality of testing, or quality of unit tests, or whatever it was. And so once we solved that, then the whole then nobody had to buy a cake anymore. So it's the technical excellence is really, really important. And so once you have that and you will keep building that, then it becomes more and more comfortable that more and more people are touching any piece of code, even the very crucial ones. I've seen architectural community slowly becomes architectural review committee. You now have a dependency. How do you ensure that doesn't happen? Yeah, in less, the reason why that in fact cannot happen, at least if they listen to the guidance, is that the architectural community does not have any official authority. And so essentially means that architectural decision can be overruled by any of the team, or any architectural guidance from architectural community can be overruled by any team. So the teams remain to have an authority officially. Okay, so therefore, a team can disregard any guidance. So that's how it's being solved. And having said that, in reality, what happens is that because the team members from teams are participants in a community, it's not very likely that the team is going to disregard what the community discusses, unless you have some weird discrepancy within a team, that the person participating in architectural community doesn't talk to his teammates, and so that might be the problem. But in any case, this is how it's being solved. If you allow all members of all teams to change anything, it might be a good practice to let the ones that originally built the microservices do the code review. Would you call it an anti-pattern to let them act as kind of an owner of the microservice? Yes, I would definitely not use word owner of the microservice or component or whatever, because we really want to have responsibility at the level of the person which is changing the code. So the team that needs to change the code retains the responsibility. This is really important because there is a psychological effect. Once a team knows that somebody else is going to review, they also have a more tendency to screw up and not learn, because they want to get over with it. They don't feel ownership for it. If you don't feel ownership for something, then you're going to mess with it. Okay, they really need to feel owner of it. And so still having said that, as I mentioned, you have things like a component mentor or service mentor, whatever you want to call it, and which acts as a reflection point. And so the people generally ask for help and assistance and review, etc. Yeah. Since we want teams to be able to touch any code system, do you see more value in standardizing tools across teams? Yes and no. Standardization is a very tricky thing. I see much more problem of over-standardization than under-standardization. And I would not even standardize development tool like everybody needs to use IntelliJ or something like that. What you want to standardize is it's the code that should be standardized, and that's being continuously developed and improved, etc. But the tools used to produce the code, tests or whatever it is, doesn't need to be standardized generally. And having said that, people are gonna obviously share with each other their knowledge and practices and stuff, etc. And at some point they might be annoyed that everybody's using different tools because they want to pair up with each other often. So they, at some point they agree everybody have to be expert in Vim, because then you at least can work together. And then when you're not pairing up, then you can use whatever you want. What could be consequences of mixing Basecamp's Shapeup with a Scrum inside 6 weeks runs? It's about assigning people to initiatives each 6 weeks run, having direct teams setups each time. Yeah, it's a very, very interesting one. I know about Shapeup, and I read it recently, the document and the whole approach. It's quite interesting, and actually, I'm quite intrigued by it. It looks very nice, and in fact, it makes me think about the whole concept of sprints as in Scrum. I think that's actually debatable. I really don't see a concept of sprints as the only way to do product development. This 6 weeks runs is actually interesting, because these 6 weeks runs doesn't mean that they are not iterating. They're iterating within those 6 weeks, but it's not constrained by the sprints of 2 weeks or something. So yeah, I mean, it's something very interesting to explore. But to be honest, I'm just barely touching the subject, so I don't have much to say about it besides this.
Yeah, Viktor, this is Gene. This is actually great. T-2 for everyone, so we're gonna have people dropping. Maybe one more question. I had one of my own for you, just as an anchor, but let's see if someone else can, you know.
I dropped one in the chat. Hopefully it came through.
Yeah, go ahead, Doug.
It's related to, you know, APIs are all the rage, and often microservices are communicating with each other via APIs. And in Martin Fowler's contract testing article, I always had the impression that microservices could release separately from each other and even deploy separately via contract testing. So could you just talk a little bit more about how that doesn't address the problem? Does that make sense?
It's the contract testing or not, whatever concept that we think about, it boils down to the if you go a level deeper, it's always the same problem of connectors, and let's call it very generic way, and so it's completely dependent on how well things are separated or not, and so if you have one thing that you want to get done, and you have two parts that need to somehow work through the contract, and you test the contract, that in theory works until you do integration, and then it doesn't work. And why does it in theory work? Is because it assumes that the contract testing is done really, really well, and the contracts are done really, really well, which never really happens. Let me give you an example. I have a lightning here in my room, and at some point I turn on my light and it starts to flicker in a video, okay? And so it's the same power, same light, same thing, etc. And here it flickers, but it doesn't flicker in US, for example, with the same camera. And then I found out the difference is the frequency. So the frequency in here is 50 hertz, and in Europe is 60 hertz. Is that a part of the contract? No, it just happens to be one part which hasn't been put in a contract. And that's what you get in software all the time, basically. And it's way more complicated than I just talk about this light. And that's the problem. And you always have this stuff. It doesn't matter really whatever practice we adapt. The problem is that the software is becoming more complex. You can, having said that, the practice of contract testing is a really good one. It's an important practice, but it doesn't solve this problem.
All right, I think we're at the hour. Well, that was really good. Viktor, I want to personally thank you for stepping up and taking this call from all across the globe, all the way across the globe. Let's wrap up at this point. I want to wish to everyone to stay safe, healthy, and your information is freely available. I'm going to make it very transparent on the meetup and on my site. Got your slide deck, and I will zap the video in the next couple of hours. At the same location. It's pinged in the chat, by the way, at the very top, folks. Hopefully we can have you back in the studio maybe in a couple of weeks, something, or whenever you can.
Sure.
Thank you guys for joining. Look out for more meetups and more invites. And we have another colleague of ours, Viktor's and mine, Jürgen de Schmet from Belgium, speaking in a couple of weeks. Of course, you're welcome to join as well. We're going to wrap. Thank you all for joining. Go back to your work or whatever you do, whatever your time zone is. Okay? And I'm going to stop recording. All the best.
Thank you.
Viktor.
Thanks. Great talk.
Thanks, buddy.
Thank you.
Yeah, cheers.